All right, so in today's video, we're actually going to be doing some inequalities practice. We're going to be using Desmos for a lot of this, just so that we can see what our inequality is going to look like graphically. And we're going to do a few examples where we actually are going to test out points and see which one falls in the inequality as it should. So remember, an inequality basically gives us a region of multiple points that can work where if the statement would be true. So if it says that something is greater than that, then if we were to plug in those values for x and y, it would be a true statement. If it wasn't a true statement, then obviously that point didn't fall in the shaded region. So if we're looking at number one says the graph of the inequality shows the coordinate plane. Which inequality does this represent? So for a couple of things that I noticed right off the get-go is I actually see that it is shaded above. Okay, so it has shading above, so we're definitely going to look for that when we see it on the graph. And the other thing that I see is it has a dashed line. Now remember, in order to be a dashed line, it doesn't have an equal to, so no equal to, okay? All right, so I'm just going to start graphing these and let's look and see which ones have the correct qualities that we're looking for. So when I look at this one, it's going to graph it in any color. It just randomly picks it as you graph each one. But what I noticed for this one is I can see that it is a dashed line, which makes it that part true, but it's shaded below the line. So since it's shaded below the line, we're going to go ahead and get rid of that answer choice. Okay, so for B, it's basically the same setup, except for this time we have greater than. And this time I do have a dashed line and it's shaded above. So now I need to check a few more things to make sure this is correct. So I have a y-intercept at -4, which I can see I do have a y-intercept at -4, and I have an x-intercept at 6, and that is also true. So once you figure out that it has the shading and the type of line, always check the y-intercept and maybe the slope and make sure that that also is the correct values. So the correct answer here would be B. Okay. All right, so for number 2, very similar problem. Obviously, the formatting of our equations are a little bit different, but this time I have shading below the line. So all of the shading is below the line. And I have a solid line. So the solid line means that it's equal to. All right, so we're going to come back over here and we're going to graph this or type this problem in so it can be graphed. So we have 4 minus x. All right, so here I can clearly see that the shading here is above. It is solid, but it's a completely different direction, so that's not going to work. For B, that one is less than or equal to. Still, even though it's less than, if I come over here and I check my value, so I see I have a y-intercept at -8, but my y-intercept over here is at +2. So that's not going to work for us. So A and B are gone. So now let's check out C. And remember, if you go ahead and hit the division before you type a fraction, it'll save you from having to do parentheses. So again, I have a solid line, but this time the shading is above, and I don't want a shading that's above, I want a shading that's below. So if we've done this correctly, then the correct answer should be D. All right, and I can see that it is shaded below. I'm still going to check those x and y intercepts. So I have a y-intercept at 2 and an x-intercept at 4. So the correct answer for that one is D. All right, so this one just gives us the equation, and the equation asks us which one matches the correct graph. So I'm going to plug this in, and we're going to write down a few things that we see about it. And so when I look at my graph over here in Desmos, I can see that it's got shading below, and it's a dashed line. Okay, so shading below and a dashed line. So if I look at A, that's shading below. B is also shading, so they all have shading below, so you can't get rid of those. But we have a dashed line. So A has a solid line, and I don't want a solid line, so we're going to get rid of A. And C also has a solid line. So we're going to have to choose between B and D. So the question is All right, so my y-intercept is around 1.6, which is true, somewhere around 1.6. But I need to look at the direction of the slope. So if I look at my line in Desmos, I should see if, like I read a book, if I read the graph from left to right, I should see that that line is going to go up. And if that line is going up, the only line that goes up the same way is going to be B. D is actually from left to right going down. All right, so very similar problem, just in a different formatting. All right, so for this particular one, we're looking for a graph that is shaded below, because it's shaded below the line, and it is dashed. All right, so if we look at our answer choices, this one is shaded below, this one is shaded below. C is actually shaded above, so we're going to get rid of C. And D is also shaded above, so we're looking for which one matches this graph. Well, again, my shading, I have dashed lines for all of them, but my shading, if I look at the line is decreasing from left to right. So the only one that's decreasing from left to right is A. And of course, I can check those x and y intercepts. So I have a y-intercept at 1 and an x-intercept around 0.5, which is true for A. All right, same thing for number 5. I can see that I have a solid line, and it's going to be shaded above. So all of them have solid lines. A is actually shaded below, so we're going to get rid of A. B is shaded above, so we're going to keep B. C is shaded below, so we're going to get rid of C. And D is shaded below. So our graph over here is going up from left to right. So the only one that's going up from left to right with B and D is going to be D. All right, for number 6, I'm going to pause this and let you guys try this one on your own. So my shading here is going to be below, and it's going to be dash. So the only one that's shaded below and dash and matches the graph that we're looking for is B. Now 7 is one that students normally struggle with because they don't give them the equation. You actually have to write your equation. So if I write my equation, or excuse me, not my equation, my inequality. If I write my inequality, you're going to have to read this and identify some keywords here. So it says in this problem, it says that inequality in which y must be at least. So if I say I have at least $5, that means I have $5 or more. So at least means greater than or equal to. Okay? So it always seems kind of backwards with the wording, but when you say it in a sentence, it makes sense. So if I say I have at least $5, I have $5 or more, which is greater than or equal to. So that means that my equation is going to be y is greater than or equal to, and I have 5 greater than 3 times x. So greater than is going to be adding, so we're going to say 3 times x plus 5. And again, once we're able to write it, at that point, all we have to do is put it into Desmos. So we need a solid line, and we need a solid line that is shaded above. So if we're looking for a solid line that's shaded above, then we're going to get rid of A because A is shaded below. B is shaded below. So we're stuck between C and D, and they're both shaded above. I guess the difference is going to be our x and y-intercept. So I have a y-intercept here at 5 for D. This one is down here at -5. Okay? All right, so for this one, I have y is greater than or equal to 3x minus 2. And given that, it's going to be C. Now, number 9 is a word problem where it gives it to you in written format, and you have to identify your key pieces. So when I'm looking at this, I can see that it's shaded below the line, okay, and it is solid. So we're going to definitely be looking at that, but the key here is it's only in quadrant 1. So quadrant 1 is what we're going to be focused on. So the first one, so I'm actually going to kind of forget about the apples and oranges that's being described here. I'm just going to read it based off of the variables. So y minus 2 times the number of oranges, we're going to get rid of that. So 2 times x is at most 5. So y minus 2 times x is at most 5. So at most, if I have at most $5, that means I have $5 or less. So this is going to be less than or equal to 5. So if I graph this, I have y minus 2x is less than or equal to 5. Well, if I look at just quadrant 1, so I'm going to kind of focus in on quadrant 1, we can clearly see that that shading does not work and the line's going the wrong way. So we're going to get rid of A. All right, so for my next problem, or my next example, again, I'm going to get rid of apples and oranges. I'm just going to focus on what it's saying. Y minus half of x, so half means 1/2, is at most, so at most is going to be less than or equal to 5. So we're going to try that one again. So I'm just going to come here and add in 1/2. It's basically the same problem except for 1/2 and 2. Again, if I focus on quadrant 1, I can see it's going in the wrong direction, so B is not going to work either. All right, C. So this time I have y plus 2 times x is at most 5. So at most is going to be less than or equal to 5. So we're going to change it to y plus 2. And this one actually is starting to show that shape, and we're going to check those y-intercepts. I have it at 5, and I have it at 2.5, which is exactly where it crosses, so the correct answer is C. All right, for B, so this one's a little bit different, but regardless, Desmos can still graph it for you. So I have x is greater than or equal to -2. And if I look at that, so greater than, it's going to be shaded to the right because we're talking about just the x values that are greater than -2. So it's going to be shaded to the positive direction. Now, I am going to do this one just a tad bit different for number 11. I'm going to show you how to do it in Desmos, and I'm going to show you how to check it by plugging in your values. So I'm going to start by saying if I graph it in Desmos and I have y is greater than or equal to -3x plus 6. Okay, so a solution is a point in the shaded region. Now, when I'm talking about the shaded region, I'm talking about anywhere you see blue. Now, I have a dash line, so it can't be on the dash line because remember, a dash line means it's not equal to. So if I look at this first point and I put in 0, 6, and my point is on the dash line, that cannot be an answer choice because the line itself is not solid. Now, if I check A, so I have 0, 6, and 0, 6 is your x and this is your y. I'm going to plug in those values. So I'm going to plug them into here. Okay. So if I have 6 greater than -3 times 0 plus 6. I'm actually going to change these to a different color just to make sure we're aware of where I'm plugging in stuff here. Okay. So now I'm just going to simplify that, and I should get 6 is greater than, so that's going to be 0, that cancels. 6 is not greater than 6, so this is not a true statement, which confirms that A is not the correct answer. All right, so then I have 1, -2. So 1, -2 is not in the shaded region. So since it's not in the shaded region, it is not a solution. Again, I can check that answer choice. So I have -2 is greater than -3 times 1 plus 6. So these are the two pieces that I just plugged in. So I have -2 and 1. All right, so negative 2, is that greater than negative 3 times 1 is negative 3, plus 6 is going to be negative or positive 3. That is not a true statement either, so which is why it's not in the shaded region. So B is not correct. So the next one is just 1, positive 2. And it almost looks like it, but if you zoom in, you can see that it's outside the shaded region as well. You can again check that. So I have 1, 2. So 2 is greater than negative 3 times 1 plus 6. We already figured out that that equaled 3, and 2 is not greater than 3, so that's not a true statement. So the last one is 4, 5. All right, so 4, 5 is clearly in the shaded region, but let's see how it looks after I've plugged it in. All right, so with 4, 5, I have that 5 is greater than negative 3 times 4 plus 6. All right, again, I plugged in 5 as my y value, 4 is my x value. So is 5 greater than, so negative 3 times 4 is going to be negative 12 plus 6, so that's going to give me negative 6. 5 is greater than 4. This is a true statement, which is why it's in the shaded region. Okay, so just kind of keep in mind to check yourself and make sure you've gotten the correct, it's got to be in that shaded area. It can be on a solid line. If it's on a solid line, then it is true. If it's on a dashed line, then it is not true. Okay, because remember, dashed lines are not included. All right, and our last one, yeah, this is our last one. And our last one, it says, which quadrants do I have solutions for this problem? Now, let's think about our quadrants for those of you that may have forgotten. So when I do quadrants, I think about the letter C. So I start C here, and I circle around, and I end here. So where I start, this is 1, 2, 3, 4. And of course, they normally have it in Roman numerals, so it's like one I, 2 I's, 3 I's, and then an I and a V. All right, so I just want to see what quadrants I have shading. So if I look and I graph this in Desmos, I should see, if I check all quadrants, so I definitely have some shading in quadrant 1. So we have shading in quadrant 1. I have shading in quadrant 2. I do not have any shading in quadrant 3. If I can keep zooming out, quadrant 3 never has any shading, so I'm not going to check that one off. And I have shading in quadrant 4. So the answer choice that has 1, 2, and 4 is going to be B. Now, as always, if you guys need any extra help, don't hesitate to contact us and ask those questions. And if you have any other questions as far as navigation, again, contact us.